Welcome to Mr. Chalk's Revision Tips. In this video, we will look at ionic bonding, simple ionic structures, and giant ionic structures. So, in ionic bonding, ionic bonding is the complete transfer of electrons between atoms. This either makes them positive, so this is where they lose electrons, negative, where they gain electrons. And remember, electrons are negatively charged. So, if we remember, an atom is a fundamental piece of atom. An atom itself is made up of three tiny kinds of particles, or subatomic particles. So it's made of protons, neutrons, and electrons. So the protons and neutrons make up the centre, which is called the nucleus, and the electrons fly around the outside. Some key phrases or key words that we need to know are the atoms. So atoms, like we've just said, consist of a nucleus made up of protons and neutrons, and electrons fly around it. Electrons are contained in shells around the nucleus and have a negative charge. The nucleus is the centre of the atom and is made of protons and neutrons, and it has a positive charge. Neutrons are found in the nucleus of the atom, have a mass of 1 but have no charge, and protons are also found in the nucleus, have a mass of 1 and have a positive charge. So if we think about these three short questions, so what is the name of the central part of the atom? What is the name of the particle with no charge? And what is the name of the particle with a negative charge? Just have a think about this. And so the centre is the nucleus, the neutron has no charge, and the electron has a negative charge. The electronic structure of an atom is a description of how the electrons are arranged around the nucleus. So it can be shown by a diagram like the one on the left, right even. There are a few things that we need to remember. The first shell can hold 2 electrons, and all of the other shells can hold up to 8 electrons. After we go by or past 4 electrons on a shell, then we start pairing them up. So if we think about this question, the diagram below shows the electronic structure of a calcium atom and an oxygen atom. Describe fully what happens to its electrons when a calcium atom forms a calcium ion. So there are diagrams. And the things that we'll need to talk about is that the calcium atom is going to lose 2 electrons, and because it loses 2 electrons, it gains a charge of +2. So when we're thinking about ionic bonding, it's always important to consider the charges. Positive and negative ions form when metals react with non-metals by transferring electrons. The oppositely charged ions are strongly attracted to each other by electrostatic forces, forming an ionic bond. A dot and cross diagram or a dot and cross model can show how these electrons have been transferred. The electrons from one atom are shown as dots, while the electrons from another atom are shown as crosses. So for example, when sodium reacts with chlorine, electrons are transferred from the sodium atom to the chlorine atom. So the diagram is a nice, easy way to represent this. So if we have a look at this question. So sodium and chlorine both want to go and get a full outer shell. So they both want to get 8 electrons in their outer shell. So sodium needs to lose 1 electron, chlorine needs to gain 1 electron. So the electron sodium or a sodium atom loses is accepted by the chlorine atom. So the chlorine atom gains a negative charge and the sodium atom gains a positive charge, and they form a molecule of sodium chloride. So if we have a look at this question, so the diagram shows how magnesium and iodine atoms form magnesium iodide. only the outer shell of electrons are shown. Right? This is because only the outer shell of electrons are actually involved in the bonding. Describe as fully as you can what happens when magnesium reacts with iodine to make magnesium iodide. So some things that you could include in your answer is that one magnesium is reacting with two iodine atoms. The magnesium is losing 2 electrons. Each iodine is gaining 1 electron. They're both forming ions. The iodide ion has a negative charge. The magnesium ion has a positive charge or a +2 charge. And eventually they'll go and form a giant lattice structure. An ionic lattice is held together by strong electrostatic forces of attraction between oppositely charged ions. The forces act in all directions in the lattice. So this is called giant ionic bonding. A good example is something like sodium iodide, but any sort of salt acts in the same way. So key things that we need to think about when describing giant ionic structures is that oppositely charged ions are attracting each other. So in this case, each sodium ion is surrounded by iodine ions and vice versa. Sodium iodide has a high melting point because it has lots of bonds. It will dissolve in water and will be able to conduct electricity once it's dissolved in water because the ions can then move around. And it's brittle because you only need to slide the layer over by just one atom to have charges that are alike next to each other, which would cause them to repel. So calcium oxide is an ionic compound. Why do ionic compounds have high melting points? Your answer would need to include something like there's many bonds, the bonds between them are strong, so therefore lots of energy or a high temperature would be required to go and break all of these bonds.
Thanks for watching.